well. I'm going to retain water because water follows salt. So my end result here, because this is circulating, angiotensin 1 and angiotensin 2 is circulating, it would trigger the cortex of my adrenal gland to release aldosterone. So now, this will cause me to what? Increase volume. I'm reabsorbing salt. I'm reabsorbing water back into my body. So I'm increasing volume. So now, another thing that's happening that we get ready to add, because of the influence of my aldosterone, this represents my hypothalamus sitting in the diencephalon. The hypothalamus controls which one of my pituitary areas, both of them right, but what I want to say is the hypothalamus will trigger the release of ADH. ADH is what?
Antidiuretic hormone.
Antidiuretic hormone. What does that cause my body to do?
Acts on the thirst center to retain water.
I'm retaining water again. So that goes right along with what? Aldosterone. So antidiuretic hormone will be released by my posterior pituitary gland. Now anterior and posterior, I guess it's better right here. Anterior and posterior. ADH will be released by the posterior portion. Posterior pituitary gland. And this circulating will also cause my body to retain fluid. The only thing that I know of right now in my mind that really inhibits that is what? You guys know? Alcohol. Okay, so when you do this renin-angiotensin mechanism, I want to see this information. I want to see that you understand the information here, because this is the mechanism that's working. We see that we're retaining volume here, so we're increasing volume. We see here we're increasing our resistance, so we get an increase in pressure. Here we're also increasing our volume. Those things will allow my pressure to go back up. Period. Period. Anytime you're dealing with this mechanism, it's going to deal with volume. So, if my pressure is low, how does that affect my glomerular filtration rate? Let's say, and I'm saying that if it's affecting my GFR, how will it affect it?
It's too low for you to filter it out. It's not enough pressure to push it out into the podocytes and stuff.
If my pressure is too low, am I reabsorbing too much?
No, you're too good. Oh, wait.
Am I? Because it's moving what? Is it moving fast or slow?
Slow.
Yeah.
Everything. Even toxins. Do we need to retain toxins?
No.
No, we do not.
And that's what's going on with the renal failure patients, that it's too low.
Now, renal failure, you mean the kidney shut down altogether? You're talking about shutting down. It probably starts out where it's moving too slow, but it quickly moves to something else. But that's probably got some other things acting on it too. So, here, I want to say this. This information is shown here, but really where I want you to focus at, because this is what? GFR. I have to increase my glomerular filtration rate. I have to increase this rate. This will bring me back to an increase in pressure, and it will increase my rate. I want you to look at this chart from this perspective. it's in the textbook. Not to worry. You might have to do the page number.
This chart?
It's the chart towards the end of the book in that system. Let me find it in here very quickly because I want you to look at this chart. I think it's on page 1046. 1046. Where we're looking at, to see how this chart is a little more comprehensive, and it's also showing you that posterior pituitary gland and all of that.
1041.
Is that, okay,
Yeah,
is that right?
Yeah.
All right. So, that's, yes,
So when you say that it's low blood pressure, we're saying that means the GFR is too slow.
probably.
So therefore, if you had a high blood pressure, would it mean it's going too fast?
Yes,
Because it's pumping it too fast. So
Yes.
not enough is getting reabsorbed.
that's right.
Okay.
Not enough of even the good stuff. So the bad stuff you want it to leave, but you don't want all the good stuff to leave because you need your glucose. You need some of your potassium, you need some of your chloride, you need some of your bicarbonated ion. So if everything is moving too fast, or if I have an increase in pressure here, what would happen to this? What would happen to what I just talked about if it's moving, if my pressure, instead of me having low pressure,
You wouldn't release
if I had the whole increase in pressure, what would be happening there?
Too much is gonna filter out.
It's moving so fast, am I reabsorbing?
No.
So, what would happen to this mechanism though? Yeah, everything would inhibit. Everything would be inhibited.
Would it be
So-
a different process? Like, you know how that releases renin, would it be something else to stimulate vasodilation?
Actually, it would just inhibit.
Okay.
It wouldn't actually be a total different process.
In the book, that chapter, that other chart you're talking about is in chapter 26 in the book.